Hello everyone, I'm here to present the work entitled Empowering the Human as the Fitness Function in Search-Based Model-Driven Engineering, carried out by Francisca Pérez, Jaime Font, Lorena Arcega and Carlos Cetina, members of the SBMDE research group from Universidad San Jorge, that has been applied for the 19th Annual Humies Awards. But let me introduce myself. I'm Sir Isaac Newton. Some of you may know me for my work in classical mechanics, but today I'm here to tell you a story about search-based software engineering. The story begins in 2001 when the term was coined. Search-based software engineering refers to the application of meta-heuristic search techniques to address problems from the domain of software engineering. Since the term was coined, many research efforts have contributed to the evolution of the field, applying it to address many different problems. Currently, there are thousands of works around the topic of search-based software engineering that focus on different application areas of software engineering such as testing, design, maintenance, or requirements engineering. Its widespread resides mainly in the ease of application. Only 3 key ingredients are needed to reformulate a software engineering problem into a search problem: an encoding to represent and manipulate candidate solutions, a set of operators to efficiently explore the search space, and a fitness function that assesses how good is each candidate as solution to the problem. However, most of the existing works use one of the default existing encodings, like the binary string encoding, a set of default random base operators, like random mutation and single or multiple point crossover, and put most of the effort in devising a fitness function. The engineer applies his knowledge of the domain and formalizes it into an intelligent fitness function. Analyzing works on search-based model-driven engineering and interactive search-based software engineering, authors have detected that there is an inertia on search-based software engineering works. Most of those works focus on the fitness function, reusing existing binary string-based encodings and random-based operators. All the intelligence is embedded into the fitness function only. The present work breaks that inertia, applying a force into a different direction. The human is no longer providing his knowledge to create an intelligent fitness function. The human is the fitness function. However, the human is not able to evaluate millions of candidate solutions in a reasonable time. To reduce the number of fitness evaluations needed, the authors apply intelligent operators that are no longer based on random decisions, but based on the intelligence formalized by the human. In addition, to reduce even more the number of evaluations needed, the abstraction level of the encoding is raised, simplifying the search space thanks to the application of model-driven engineering to represent the problem. They call it HaFF. The work analyzes 2 surveys spanning for more than 20 years of search-based model-driven engineering and interactive search-based software engineering, respectively. Both surveys have been extended to the current date and analyzed to identify the task performed by the human. There are some works leveraging the interactivity between the human and the search process, doing filtering tasks or part of the assessing of candidates. However, no work has ever been able to effectively replace the fitness function by a human in an industrial case study. HaFF has been evaluated on an industrial problem of feature location, the task of identifying the set of software elements that realize a particular feature. This task is one of the fundamental tasks performed as part of the maintenance of software products and is a necessary step for more complex operations as software reuse, software evolution, bug localization, or traceability link recovery. All these operations represent a big effort in software maintenance. In fact, maintenance is the most consuming task within software engineering. There has been an ongoing effort for the last 5 years to address this problem of feature location with traditional fitness functions based on textual comparisons, including fitness functions based on formal concept analysis, latent semantic analysis or latent semantic indexing, topic modeling, or learning to rank fitness functions. All of them suffer from similar problems related to feature location, such as vocabulary mismatch when synonyms or polysemic words are present, or the lack of formalization of tacit knowledge into the search process. The human as fitness function approach is immune to this problem. The human is good at understanding the context and uses its complete knowledge about the domain when acting as fitness function, avoiding the issues that tamper traditional fitness functions based on textual comparisons. This results in a rise of the quality of the software elements identified that can be measured with standardized quality metrics as precision, recall, and F-measure. In fact, HaFF shows improvements of more than 20% in precision when compared to the best automatic baseline, and more than 45% when compared to the manual baseline. But do not believe my words. Let's hear it from one of the engineers from our industrial partner.
Hola, soy Óscar Sánchez, responsable de la definición de la metodología de software y de integración de sistemas en HaFF. HaFF tiene más de 100 años de experiencia diseñando y fabricando vehículos ferroviarios, tanto para Europa como para otros continentes. Contamos con fábricas y proyectos en circulación en múltiples países. Actualmente, uno de nuestros mayores retos es la integración de los sistemas y toda su complejidad, así como el desarrollo de software de manera modular que nos permita la reutilización. Con el grupo de investigación SBIT llevamos trabajando más de 8 años en una intensa colaboración donde nos han desarrollado una herramienta de modelado de software que nos permite trabajar en el dominio específico del sector ferroviario con los conceptos que manejan nuestros ingenieros de funcionalidad y que les permiten centrarse más en la funcionalidad que en la programación propiamente y en el código fuente. Habiéndose olvidado de esto, la modularidad es un concepto mucho más fácil de aplicar, así como la reutilización.
Oscar, let me take a little break. This is the tool used by HaFF engineers to search among the software of the trains for the feature that wants to be reused. In each iteration, HaFF shows the features generated by the evolutionary algorithm. Each feature is displayed using the domain-specific language used by HaFF to formalize their trains. As Oscar said, engineers love features being displayed using a representation that they master, as they can evaluate the features much more easily than if they directly browse the source code. In this area, the engineers assign a fitness score to each feature based on their relevance to be reused for a different train. With all this, we put the engineers to work as a fitness function to locate the features they want to reuse. Back to Oscar.
El hecho de trabajar con los conceptos propios de nuestro sector y de nuestros sistemas les facilita mucho el trabajo, lo cual hace que sea más eficiente y el resultado de una mayor calidad y en menor tiempo. Por tanto, la colaboración con SBIT estoy convencido de que se alargará durante muchos años.
HaFF can be applied to other domains and to other software engineering problems, and the presented work includes a set of guidelines on how to do it. For instance, HaFF could be turned into a hybrid fitness, where part of the effort of assessing candidates is carried out by a human, and another part of the effort is performed automatically by a traditional fitness function. Another option is the collaboration among a team of humans to be the fitness function, combining their knowledge of the domain and sharing the responsibility of assessing the candidates and the burden of the task. HaFF could also be applied to generate training data that serves as the basis for a simulated human that acts as the fitness function. The force applied by HaFF breaks an inertia of 20 years and opens a new era in search-based software engineering. Creating a good fitness function is not the focus anymore. The main focus of research should be now the creation of the vehicle that the human will drive to perform search-based software engineering tasks, adapting existing approaches to introduce the HaFF in the best way possible. HaFF will be a life changer on how software engineering problems are solved. There are more than 40 million developers in the world, but also 100 million of end-user developers. Developers could be able to create fitness functions for solving a software engineering problem of a particular domain. However, end-user developers are not able to formalize their knowledge in the form of a fitness function. But those end-user developers can be the fitness function for problems from their domains of expertise. This will endow scientists or domain experts from many different fields with a really powerful tool to address their problems. Thank you so much for your attention and for listening to my story about 20 years of inertia and how HaFF is the force that breaks that inertia. I hope that you enjoy it and, as I do, believe that it deserves an award.